my name is David Weintrop. I am a faculty member at the University of Maryland, College Park. My appointment is primarily in the College of Education. I also have an appointment in the College of Information Studies and an affiliate appointment in the Computer Science Department. My background, I was a software developer for a bunch of years before getting interested in education and going back to school and getting a PhD in learning sciences and doing a bunch of research on the role of block-based programming in K-12 computer science. Does it make sense? Is it a good idea to introduce students to programming via tools like Scratch in the context of a classroom when we have a teacher, when we have a curriculum? Does that make sense? And if so, how, why, and when? The short answer to that question is yes, it does make sense. There's now a growing body of research showing that block-based programming can be productive to introduce kids to programming. But the caveat that goes along with that is just because a learner knows how to program in a blocks-based environment does not mean they know how to program in a text-based environment. So there's some interesting findings of kids doing really well in block-based tools, and then we move them on to Python, and then it seems like they're starting back at ground one, or kind of starting back at the beginning. And so then there's interesting kind of pedagogical and tool design questions about how can we take the practices they've developed and conceptual understanding that they've built from block-based tools and have that persist as it moves into text-based environments. And actually have a grad student who's doing his dissertation on exactly that question. So if people are interested, I'm very happy to connect you with my student, Jimmy. So more recently, I've been doing some other things. I have a middle school computer science curriculum, but I know called Scratch Encore, that I've been collaborating with some CS teachers across the state that I think is pretty cool and fun and exciting. But I know we mostly have high school folks here tonight. I've also been working on a high school data science curriculum, thinking about what does it look like what is it that students need to know to be data literate, informed citizens, and what's the role of computing and computer science in teaching data science? What's different about learning data science once you know some programming as opposed to students who are brand new who have never taken any computer science. And then what I'm sharing on the screen here and what I'm going to talk a bit about tonight is like everyone in the education space, and it seems like just about everyone full stop, trying to make sense of these new, crazy, powerful, at times scary, at times, incredible, inspirational, generative AI models. And in this case, in particular, we ran a study trying to understand whether or not tools like OpenAI's Codex, which is a large language model that can be embedded within an integrated development environment, and ends up having features similar to something like ChatGPT, where you can just say, hey, ChatGPT, hey, OpenAI, can you write me a program that does generate a random number from 1 to 100 and display it if it's greater than 50? You can just kind of make that request inside the editor where you're writing your programs, and it'll just spit out something that's, at times kind of scarily close to exactly what you want it to do. Yeah, so I'm going to share a little bit about this research project that I was a part of. It was led by Majid Kazimbatar at University of Toronto, along with a handful of collaborators, including Justin Chow, Carl Katoma, Barb Erickson at University of Michigan, and Toby Grossman, who's Majid's advisor at University of Toronto. I'm just going to kind of roll through this. For the folks who are here, if you have questions or if I fly through something that sounds interesting or exciting, please do feel free to interrupt. I think I'll give a couple like very brief demos, but then try and dive into the findings, what I think are the interesting things. So I'll give you guys a little bit of a crash course on this, and then hopefully we'll have some time at the end to chat a little bit about what this might mean for your classrooms. Okay, so right, large language models trained on code. So tools like OpenAI, tools like Bard, all that good stuff were created by computer scientists. So it's unsurprising that computer scientists, who often spend lots of time programming, that having these types of tools write programs for them would be one of the earlier kind of use cases for these types of technologies, in part because they are trained on text, and I guess Microsoft in particular, given that it owns GitHub, has hundreds of millions of lines of code to train these large language models on. So between having the data readily available, that data being available in text form that can be queried and accessed and compiled, early on, large language models were being pointed at programming tasks. And I don't know if people have done this before, but I have another project with a collaborator at the College of Information Studies who teaches the intro programming class, and he was saying when ChatGPT 3.5 came out, he went through and fed in all of his programming assignments from the course, and just straight up copy and pasted the assignment that he gives to students and pasted it into ChatGPT's text window. So there's no like prompt engineering happening. It's just straight up copy and paste. And he came away with the feeling that ChatGPT would get like a pretty strong B in his course. Like, it was making mistakes, but at the same time, like, it got a B in the course with, this is a couple months ago, and there was, no prompt engineering, no second tries, nothing like that, which was a real wake-up call. And he's definitely not unique in terms of just kind of computing education folks generally thinking about the role of tools like ChatGPT and Codex. So, for example, if folks haven't seen Codex before, like I said, Codex is essentially like a chatbot embedded within an integrated development environment. So this is an example where you would set up a program, and then in your comments, you could make a request of Copilot. And then kind of in this case, you're typing out a function header to kind of define the inputs and the return type. And then Copilot just creates correct function in code, exactly what you want it to be. And again, what's surprising and a little wild about this, in this case, it's saying the request is to determine the sentiment of text and use a web service. So this isn't even like Copilot living in its own ecosystem on its own little computer. It's just saying like, hey, find some web service on the web that does sentiment analysis, figure out the format it accepts and the response that it takes, or the response that it gives back, and then it finds all that, does all the wiring up, and then sure enough writes a functional program. Again, pretty wild stuff. And so there are all sorts of roles that generative AI and conversational AI can play in programming. So in some cases, this means you can feed in natural language and get back code. So we call this code generation. This would be an example of what we just saw, or this would be my collaborator kind of copying and pasting his assignments for students and then getting code back. There's also uses for code to natural language. You could imagine if there's a chunk of code that you don't understand or a student doesn't understand, you could feed that code to the large language model and say, hey, can you explain to me what this means so that a fifth grader could understand it? And then sure enough, you'll get a step-by-step explanation of like what the algorithm is and how it fits together. And then what we're starting to see here with tools like Copilot is this code to code. So you're already working within a large code base, and you're using the tool to analyze the code base, understand the current state of things, understand variables and scope and all that good stuff, and then kind of have it complete the program or add some functionality to it. Which again is pretty wild. So looking across these different environments, there's a bunch of benefits from a pedagogical perspective, like what might the role of these tools be for education? So there's benefits like allowing students to no longer be stressed or focused on syntax and instead be thinking about things like problem solving and algorithms and how to decompose problems to generate the behavior that you want. There are benefits like helping with debugging or fixing syntax errors, right? The compiler is already doing some of this work, but if a student is confused by something, they can kind of make a request of the Copilot or make a request of the generative AI and say, hey, can you help me with this? Explain what's happening. Why isn't this working? And it can provide feedback as a very kind of customized tutor. And then there's other worlds, and we all know this, that in computer science, rarely is there ever one correct solution. So you could imagine a world where you can say, hey, ChatGPT, hey, Bard, can you give me 5 different ways to solve this problem? And that, again, feels like it could be a generative pedagogical exercise, both to highlight the fact that there isn't one solution, but also just kind of as fodder for discussions about like, oh, well, what's the difference between here's a for loop and here's a while loop, and then this one, here's a solution with recursion, and here's a solution with iteration and escape clauses, like all sorts of kind of potential cool generative discussions. That being said, as we all know, it is not without its drawbacks. For example, there are challenges around what we're now have come to call prompt engineering. So this is saying, hey, AI, Bard, whoever, can you do this? Can you do A for me? And you end up getting back B or A prime or something that's not quite what you had requested. And depending on what you're asking and the sophistication of the request and the requester's kind of knowledge of programming, blah, 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 that might actually be hard to suss out where you think it's doing one thing and it's actually doing something else. A second example is the need to understand, verify, and use AI-generated code. Like one of the major concerns here, well, one of a handful of concerns, is a world where people are increasingly using code that's been generated by AI without themselves totally understanding what it does. And it's not that it's pretty easy to imagine scenarios where people think a piece of software works one way and it actually works another way, and that could actually have pretty serious catastrophic decisions. Right, you could imagine like if this code is being put into like a self-driving algorithm or being used like on an aircraft or something, like imagine a world where there's software being put on aircrafts or a spaceship and like people don't actually understand the nuance of everything that's happening. There's also, from an instructional perspective, there are concerns around, well, like are our students actually learning the thing? Are they learning foundational programming concepts? Are they learning how to code, or are they just learning how to use a large language model to kind of get it to do what you want? This is, there's very clear parallels between kind of the existential crisis that math educators had when pocket calculators became ubiquitous and increasingly powerful. It's like, oh, wait a minute, do kids really understand what division means, or do they just know like what the division button is on a calculator? And like we're well past that, but we can see the parallels there, where it's like they're able to perform the thing, but they don't actually understand what's happening. And then certainly ethical issues. This might be a little. This is a really hot topic in my world, in undergraduate education in particular, a world where the solution to all these programs that were, well, historically solutions to coding tasks that we've given may exist on the internet, but now we have this machine trained on 100 million lines of code that you can ask it whatever you want, and it's going to give back an answer. Like, how does that interact with things like academic integrity? Is that plagiarism? Like, who do we give attribution for knowing the answer? So lots of questions about this. Answers are slowly starting to emerge. There were some kind of digging around on the internet like once ChatGPT first emerged and people were starting to understand its power. There were early quotes and it's funny because this feels like 1,000 years ago, but it was actually just January of this year, where large public school districts were chiming in saying, these are counterproductive tools. Using ChatGPT is the same as cheating. It doesn't help build critical thinking skills. So the initial reaction was kind of coming from seeing this as a threat to our world and our role as educators, and so kind of trying to just dismiss these tools altogether as not having a place in the classroom. And so what we were trying to do with this work is understand what are the impacts of using AI code generators with young students who are just learning to write code. So put another way, are tools like ChatGPT or Copilot, are they productive to help novices learn to program? Made a little more concrete, we're asking questions about code composition. How do novice programmers task performance differ with and without AI code generators? Does an AI code generator help them write code faster, more accurately, more successfully? Or does it lead them down a path where, they don't know what they're doing and they're not getting the results that they'd hoped? Does prior access to an AI code generator affect learners' ability to manually modify code? So if students spend some time with ChatGPT to try and write some programs and things like that, afterwards, are they more capable? Are they better able to modify program without the AI being present? So this is kind of like a bootstrapping question. Does an AI tool help them get started? And then once they have a program to work with, once they're modifying code that's close to what they're looking for, are they better at doing that in the absence of that same AI? And then thinking about retention, are students able to better retain computer science knowledge, programming knowledge after learning to program with generative AI or learning without generative AI? Okay, as an academic researcher, the next phase is to talk a little bit about the methods and how we went about answering this question. But I do want to pause there because I've been talking for a little while and admittedly talking kind of quickly because I'm just throwing a whole bunch of things at you. Questions, comments, concerns from anything I've shared so far?
I just wonder, how did you guys throw this together so quickly? It's like the stuff arrived on the scene, and by what was it, April, you were presenting your results of this?
Yeah, I mean, this version, I can't take any credit. I'm going to go back to the opening slide to highlight Majid again, who's the first author. Majid is a very talented software developer, and just one of those really kind of one of those people who's like interested in everything. And so he was very early into Copilot and the role that it plays, right? So this is even in his own work, he started to use Copilot. This is the uh, autocode completion large language model embedded within a programming environment. And so that got him thinking about what could be done with it. Cool.
Prim-
Okay.
Is Prim what
So
you use in Scratch Encore?
we do not use Prim. We use something similar to Prim. We do use a lot of use, modify, create as kind of like the pedagogical structure. So we provide fully functional programs, have students use those to see how concepts behave and programming language features behave, and then modify them and then write their own. So we use something a little bit different from that. But yeah, it's worth mentioning, and that brings up a good point about these technologies being pedagogy agnostic, right? It's not like Codex or ChatGPT only works with a specific instructional approach or a specific language or a specific age learner. In many ways, these are big open questions, and this work is starting to answer that a little bit around, and you'll see the way that we went about answering this question to trying to make sense of like what are productive roles for it to play and like how and when it gets used. But big open questions. Yeah, thanks for bringing that up. Okay. Um, okay, so the way that we went about answering this question is we recruited a group of programming novices who, and these are 69 middle school age kids who may or may not have had prior Scratch experience, but none of them had seen Python before. We split them into two groups. The Codex group, as a reminder, Codex is OpenAI's kind of programming language based large language model. So we had half of the students in this Codex group, meaning they had access to a large language model where they could say, hey, write me a program that's gonna, spit out, who's gonna, spit out the first 10 prime numbers or whatever. And then half of the students did not have access to to a large language model. We call this the baseline group. So we had our two conditions. The study took place over 10 sessions. The first session was introducing everyone to Scratch and doing a Scratch pretest. This is just a way for us to understand what students' knowledge was coming in, so we could kind of control for that, just in case there being a world where like there were a whole bunch of students who already knew some programming, they all end up in one condition. We then had 7 sessions for them to go through 45 assignments where they would do some code authoring and then some code modifying. I'll talk a little bit more about what that looks like. And then at the end, there was a post test right after the 7th session. And then a week later, we did another post test. And so there are these 10 sessions. One was like an intro training, 7 of these code authoring modifying pairs, and then a post test, and then a retention post test a week later. This environment was, we ran this test in an environment called Coding Steps. This is what I was alluding to before about Majid being a, this super talented software developer. So what this looks like is, here's a quick video of it. Here's the programming environment that he created. So on the left is the task description. In the middle is the programming area. And then below that is the output. And then on the top right is a code generator prompt. So you can type, or you either copy and paste or type in words into that box and click generate code, and it'll spit out the code that you're requesting. And then the bottom right is some Python documentation, because again, so either half the students saw the code generate box on the top right, but all the students saw the Python documentation. So quickly what this looks like, here's an example. Students are typing in, and so here they're asking like, how do we print things out? I realize this is going fast, and that's the documentation. Or you could type into the code generator, generate 2 random numbers between 1 and 6, click generate, and boom, out comes the thing that you want. and then type some things. Check if both dice 1 and 2 are greater than 3, spits out what you want. You can run it, and you're getting the results that you're looking for. So again, this is a world where kind of straightforward coding tasks, there's a code generator, and there's supporting Python documentation. The boring methods thing, 69 participants between the ages of 10 and 17. They were recruited from coding camps. Most of them had used Scratch in the past. None of them had used Python in the past. Boring procedure things. So in the first one, we introduced them. This was the first session was all about what is Scratch, what can you do, followed by a Scratch test. And this was to understand, and this is what the Scratch test looked like. This was to understand students' conceptual understanding of programming concepts when represented in Scratch. So we hear questions about conditional logic and iterative logic and different types of while loops and things like that. The 7 sessions I mentioned before. So this is where things were different between the 2 conditions. For students who were in the codex case, there were 33 of them, 11 female. And then for the baseline case, this is no generative AI. There were 36, 10 female. And we can see on the Scratch pretest, they were about the same, at least close enough to the same that we didn't see a significant difference. In terms of this, so there were 7 sessions, each of which had them do an authoring task and a modify task. There are some basics, which is really just kind of like, sequence and things like that. And then we had them do some activities around data types, conditionals, loops, and then arrays. And that's how we got our totaling to 45 activities. Each of those pairs, there's an authoring task and a modify task. So what that looked like was, would give them a task and ask them to write a program that, did the specific thing we're looking for. In this case, create a random number between 1 and 100 until it generates a 50. When it generates a 50, stop and say how many attempts that it took. So you're creating a random number, you're checking the value, and you have a counter, and then spit it out. So that the authoring task students would either do with the generative AI or on their own, depending on their condition. And then the second modify task was, in this case, it was you already have a working program. Let's modify it a little bit. And what we're doing here is now instead of just 50, it's saying if it's 25, 50, or 75. And importantly, for the modify task, none of the students had access to the AI code generator. So for authoring, half the students could use the AI code generator and then half couldn't. And then for modify, none of them had access to the AI code generation. And the reason for that design is to get at this question of, is a tool like ChatGPT useful for getting students up and running, like just kind of addressing the blank page syndrome type thing, but then they're on their own for modifying it. So are they learning things through making sense of reading and parsing code generated by an AI code generator? Like, is that a productive activity in terms of modifying it and learning? And then we had some post tests that included, afterwards, they had a post test that included both authoring and modification. And in this world, there was no Python documentation, no instructor support, and no AI code generators. Really, students on their own, right? They've been through 45 of these tasks, and now they're on their own. And then a week later, we did the same thing with a different set of tasks. Okay, that was a lot of setup. For those of you who haven't spent time listening to academic talks, there's a whole lot of talking about like what the question was, how do we go about answering, blah, blah, blah. Takes a very long time, and then hopefully it culminates in something big and exciting. Okay, so this is our big exciting results. So in terms of to understand the difference between the conditions, we looked at overall completion rate. Like, were students more successful at solving the authoring tasks in one with the codex versus not the codex? How long did it take for codex and not codex? And how correct were they? So again, this is looking just at the authoring tasks, codex to non-codex, or AI supported versus no AI present. So what we found was students who had access to codex, so students who had access to the code generation AI, were more successful at completing the authoring task, which isn't that surprising, right? Because to complete the task, they could just put in a correct prompt for it. So that's not that surprising. We also found that not only were they more successful at completing it, the versions that they completed were both more correct. It was in terms of being able to meet all the requirements of the program, and they did it a lot faster. So again, it's 80% correct compared to 43% correct, and 210 seconds compared to 357 seconds. So this is The kind of unsurprising, but this is saying novices who haven't programmed in Python before, having the presence of a code generator is helpful for them writing programs. Like, this isn't really that surprising because you get the AI to do it for you. This is validating something that seems intuitive. All right, let's get on to things that are a little more interesting. So if you remember, students would have to write programs either on their own or with the AI. And then the next phase was they were asked to modify that program. And we also made sure that after the manual code, before they did the modifying, all students were able to see a functional program. So if students didn't successfully complete the programming task on their own, we would provide to them a correct program so that for the modify task, everyone was starting from a functional correct program to do the modification. Also important to remember, for this part, none of the students had access to the code generator. Okay, so now we're using the same measures. We're looking at task correctness and task completion speed, how long it takes. So I'm going to ask, for the folks who are here, I'm going to ask you to put your thoughts in the chat. So for task correctness, do you think students, so remember, in this case, no one has access to the AI generated, AI to support the thing, to support the task. So do you think students who had access to the AI on the previous task did better or worse in terms of correctness compared to students who had not seen any AI? So if you think they did, if you think the codex group did better in terms of they were better able to modify the program without the presence of codex, type codex into the chat. If you think students from the baseline condition, meaning students who never saw the AI, were better able to modify a program in the absence of AI. So this is kind of looking at a near transfer task. They did some stuff with AI, and now they're being asked to do stuff without AI, or they never did anything with AI, and they still don't have AI. And the question is in which case would students do better?
It might be cheating because I sent them a link to your paper ahead of time.
Okay, well, I was going to say, no. Well, fine, Diane.
Sorry.
Same thing for who happens faster. Spoiler alert, and I think this is a little surprising, is that students who had access to the codex, the generative AI, for the first part of the task, completed their programs more correctly, modified programs more correctly, and modified those programs faster than students who had never seen the AI. And what's interesting about this is this specific task that we're looking at, they no longer had access to the AI. So having spent time with the AI in the authoring task helped them better complete modification tasks in the absence of AI. So this is a little bit surprising. And again, getting to this question, the parallel I made earlier around, like, if when students have access to calculators, do they no longer understand what division means? This would suggest in a world where they can do division with the calculators, even when they don't have the calculators, the presence of the calculator early on was productive for them to understand, to develop an understanding of what computer science content did. Okay, that was one finding. So then we also had this post test, right, where we asked them to do author some immediately after the sessions, and then a week later we asked them to do some program authoring in the absence, without any documentation, without any instructor supports, and without any code generator. As a reminder, what that looked like: 5 authoring, 5 modification, and some multiple choice immediately after, and then we had them do it again a week later. Looking at how they performed immediately after, we find no real statistically significant difference. So students were performing about the same. And again, like, in some ways, this could be kind of surprising, right? Like, you could tell yourself, oh, students who are using the codex, like, were just asking the AI to do something for them. Like, so they didn't really have to grapple with the content in any meaningful way. But we see that to not be the case because they're scoring as well as students who did not have the support of the generative AI. And we see that this similar pattern for correctness on the authoring tasks, the modifying task, and a bit of a difference in the multiple choice task, but not one that's statistically significant, which for researchers like me is the thing that we're looking for. And then, interestingly, we ran the same thing a week later, and we see a little bit of a difference here where we start to see students from the codex group performing better compared to their peers. So this is suggesting, and there's lots more work to be done here, acknowledging there's only 69 students, and we're seeing differences emerge, but they're not huge differences. And so this is something that we're conducting some follow-up studies to try and make sense of around a question of student retention, like do they better understand a week later? Do they understand these ideas, suggesting that they're better able to recall, it was more memorable, or there's kind of some more meaningful learning that was happening in terms of the presence of the codex as opposed to not having a codex. Diane, I see your question. There's some other stuff to talk about. I'm going to skip because it's a little more in the weeds. So just to the big takeaways, students having access to an AI code generator and significantly increased the code authoring performance, both in terms of correctness and speed. Not that speed is that important, but it is kind of one measure of learning. We see that for a modification task, it did not decrease their performance on those modification tasks in the absence of an AI. And then we saw some slightly increased performance on this retention task a week later, which again is something that we think is interesting and are still trying to tease apart. Okay, I've been talking at you for a while, and again, admittedly talking kind of quickly because I knew we only had limited time, but this is the team. And again, Majid was the lead author on this, so he built a tool and did the heavy lifting on this project. So, and Majid also got his master's at the University of Maryland, so he spent 2 years in College Park before heading off to Toronto to do his PhD there. So he does have some Maryland roots. So we can all kind of collectively, take some